Okay, chapter 10.3. We're still dealing with radicals. Now we're multiplying and simplifying radical expressions. We're on page 767, and we're looking at number 34. And it says, use the product rule to multiply. So I have the fifth root of 7x squared times the fifth root of 11x. So remember, the rule is, well, if they have the same root, I can multiply them together. It's like going from going from individual homes to a home together. So keep it to be the fifth root. But now I have, well, 7 times 11 is 77. X squared times x is x to the third power. These right here cannot be written as something raised to the fifth power, so this is your final answer. All right, number 37. It says simplify by factoring. So I have the square root of 20x to the third power. It also says assume that all variables in the radicand, or what I call the argument, this piece right here, represents positive real numbers. Alright, so remember this is a square root, so when I simplify, my goal is to write whatever on the inside as something raised to the second power. So let's see if we can do this. Well, 20, if I break that up, that's like saying 5 times 4, but 4 is like saying 2 squared. So 20 is really like saying 5 times 4. And then x to the third is like saying x squared times x, right? That's what it really looks like. So then x squared is just x raised to the second power, and then there's an x hanging out by himself. Now, the square, as well as, the 2 squared and the x squared, well, they get canceled out. Remember, the power and the root, if they're exactly the same, they cancel out, and they come outside. So 2x comes out. However, the 5 and the other x, they could not cancel out, so they're still on the inside. So this is simplified down to 2x times the square root of 5x. Now, because they told me that I can assume all of the answers to be positive, all of the variables to represent positive real numbers, I do not need to use absolute values. And that will be the final answer. Then number 38, I have the cube root of 54, x to the 8th, y to the 6th. So again, let's break this up. Let's break it up into our powers of 3, because our root is 3. So 54 is like saying 9 times 6, which is like saying 3 times 3, and 2 times 3. So I have 3 written 3 times. So that's like saying 3 raised to the third power times 2 times, well, x to the 8th, that's like saying x to the 6th times x squared, right? So the rule is keep the base and add the exponents. So x to the 6th is like saying x to the squared to the third power times x squared. Because remember, x to the 6th is x squared times x squared times x squared. The best way to do this is use the calculator. You can't now. The best way to do this is use the factor tree for the coefficients. And for the exponents, for the variables, I would take the exponents and divide it by the root. So 8 divided by 3. Or you can say 3 goes into 8 how many whole times? 2 whole times, right? That's why that becomes x squared. And then what's left over? 3 times 2 is 6. 8 minus 6 is 2. That's where that 2 comes from. Alright, so now we can simplify it. 3 to the third as well as x squared to the third, they cancel out with the third root, so they come out on the outside, and the 2 and the x squared didn't cancel out, so they stay on the inside. And that's factored or simplified down to this. Oh, by the way, I forgot the y to the 6th, didn't I? Well, y to the 6th is like saying y squared to the third power. Remember, take the 6 and divide it by the 3, and you get 2. Or you can say 3 goes into 6 how many whole times? 2 times. That's where that 2 comes from. And again, the 3's, they cancel, and the y squared also comes out. Okay, sorry, I forgot about the y squared. All right, last problem, number 42. It says multiply and simplify. So I have the fifth root of 2x to the fourth, y to the third, z to the fourth, times the fifth root of 8xy to the sixth, z to the seventh. So first thing first, if they have the same root, then we can multiply them together. So they both have the fifth root, so keep the root, and then multiply them together. 2 times 8 is 16, and then x to the fourth times x is x to the fifth, y to the third times y to the sixth is y to the ninth, z to the fourth times z to the seventh is z to the 11th. Great, and then make sure you rewrite each term so it's something raised to the fifth power, just like what we were doing before. So 16, is there anything that I can write to the fifth power for 16? Well, 2 to the fifth power is like saying 2 to the fifth. Does that one work? 2 times 2 is 4, 8, 16, 32. So that one doesn't work. So 16 cannot be simplified, so you leave him alone. So he's still going to be 16. What about x to the fifth power? Well, that's like saying x raised to the fifth power, right? Y to the ninth? Well, 5 goes into 9 how many whole times? Just one. Just one. So it's like saying y raised to the fifth power. And then what's going to be left over? 4 of them. Y to the fourth. And let's do the same thing for z. I'm running out of room. So this is going to become z squared to the fifth power. And there'll be 1 z left over. So remember, 5 goes into 11 how many whole times? 2 times. Make sure you're raising it to the fifth power. 2 times 5 is 10. What's left over? Just the 1. Alright, now let's simplify. This piece cancels, this cancels, and that cancels with the root. So the x, the y, and the z comes out. X, y, and z squared comes out. And who's left on the inside? 16, y to the fourth, and z. Alright, so that concludes chapter 10.3. Let me know if you have any questions.